We present Foam2Form, a novel single-material 4D printing method that programs shape change through selective foaming. Commonly in 4D printing, the material is actuated by shrinkage of PLA along its printed lines, and the shape change is designed via the arrangement of line patterns. However, these patterns can only be printed on the horizontal plane, which limits the actuation directions. In addition, there's also undesired deformation besides the desired actuation since all the lines shrink. This anisotropic shrinkage causes dimensional instability and limits the designs to small or planar shapes. Foam2Form proposes an alternative method to overcome these challenges. We use a foaming PLA filament that can be printed in a foamed or non-foamed state, depending on the nozzle temperature. While non-foamed PLA has shape memory, foamed PLA loses the shape memory property. We utilize this to design shape change by selectively printing the object at foamed and non-foamed states. Only the desired parts experience shape change upon heat activation, while the rest of the object preserves its form. Thus, the core of our method is the ability to deactivate shape memory selectively through foaming. In comparison to regular PLA, the foamed PLA shows significantly less shrinking when heated, preventing undesired deformation and preserving the form of the object. We leverage the shape stability of foamed PLA to design actuators with more freedom in size and direction in the 3D space. Foam2Form enables large three-dimensional forms in shape-changing interfaces by allowing the design of local actuators and the shape preservation in the remaining parts. Not relying on printing patterns for passive and restrictive segments provides us with unique capabilities such as shape morphing thin walls, actuation on 3D forms, and complex 3D actuators on tilted and curved surfaces. With Foam2Form, we present a novel approach to expand the design flexibility and complexity in single-material shape-changing interfaces. We showcase the potential of foaming PLA in 4D printing, and with our initial application examples, we highlight the design capabilities.